Hello grade 11s. Today I'm looking at page 83 from the workbook. It's still on the section of the curve of interpenetration and development. They have given you the top view with a hexagonal prism and a square branch pipe, and they've given you an incomplete view of the front view. So we're going to have to do the complete top view as it is there. We're going to need to have the auxiliary view here so that we can get the measurements and then work out the curve of interpenetration. They've asked you to develop the square prism. So to get my 15-degree angle, we've put your set squares together like that. I then started by drawing the vertical, which was tilted at 15 degrees, and at that point I drew my circle, then where my vertical line, sorry, the 15-degree line, cut the circle. I put my compass and drew my tennis ball, and now I can join up the points. There is my completed branch pipe with the circle with a diameter of 28 and then my 45-degree tangents on the outside. I've projected my lines up from my top view to get my front view. The height was 68, and at a measurement of 12 here we've projected a 30-degree line to get the branch pipe. I've then projected a right angle here so that I can see the height of the branch pipe. I'm going to take the measurements off the branch pipe construction in my auxiliary view. So I'm measuring half the distance because I can then mark it off twice. I bring it up to my front view and mark that off. I've labeled the auxiliary view of the branch pipe in my front view, A, B, C and D. This is an accurate representation of the auxiliary view. Now remember, to do the labeling correctly, we need to remember that this was tilted at 30 degrees, so if we had to bring it down to the horizontal, we would have had the labeling as such. And now to get it into the top view, we have to rotate our labeling by 90 degrees. I generally do it in the same direction that I've labeled, so clockwise. So if A is that point, I've got to turn it 90 degrees, and my labeling would then be as follows. To find my points, I'm going to now project down the edges of each point. So there is A matching A, here's B and D, there's B, there's C, and my final point C. Let's join up those points. I'm now going to look at finding my curve of interpenetration. So what we have to do is follow where our respective points hit and match them up with the points being projected here in the front view. The other point that we're going to need to find is the turning point. In other words, where the shape goes around and follows the shape of the hexagon. This point is quite relevant because everything behind that point will be in hidden detail. So I'm going to find point B, and I'm going to find my turning point. My first point is point B, so I follow to where that hits my main pipe, and I'm going to project a vertical line where that intersects with my B line. That will give me point B. Now I need to find the turning point. Now we don't have any turning point here. We could use the auxiliary view, but with a branch pipe that is tilted, we can use the branch pipe. How does that work? So I project my line to my branch pipe. I can then take where it hits the branch pipe, project those lines up vertically, and do it on the same at the bottom edge. Now here is my turning point, and I now need to project my 30-degree line to find where this point is. There is my one turning point, and my second turning point. There is the visible part of that, my turning point to point B to the turning point on the other side. Now the remaining points that I'm going to find, so that's points A and C and D, are going to be in hidden detail. There is point A, and I need to extend to find point C. And my last point is point D, very close to the edge here. There is point D. And I'm going to join those up in hidden detail now. There is the hidden detail for those points. So going from our turning point to C, to D, A, and back to the turning point. To finish off, just do the lines that are joining up. A little bit of hidden detail at the bottom line. The best place to do your branch pipe is somewhere where you could project perpendicular to the slope. So it would be down here, but unfortunately that would interfere with the other drawings. So what I'm going to just do now is I've projected a horizontal line, in this case in line with the bottom of my front view, and I'm now going to mark off the length of the side of my square. And then I'm going to get the length dimensions from the front view. I've marked off my width dimensions, which I've got off my auxiliary view, and now I need the height dimensions or length dimensions, which I'm going to get off the front view. Remember, we can't get in this development all the measurements off the same view. So for the top view, I've used the width measurements, and for the front view I'm going to use the height measurements. My first point is A. I've taken the distance from A to where point A is, and I transfer that measurement to my development. Same process for point B. Take my distance at B, mark it off. Take my distance at C, transfer that. The last of the corners is point D. and transfer that. To finish this off, I now need to get my turning points. And my turning points, if we look at our top view, are between point A and B and B and C. So now we need to get the width dimension of the top view. Now this isn't the true length, so what we need to do, we need to take it across to the true length, which is in the auxiliary view. So I project my turning point across here, and this is going to give me the true length for my turning point. Get that distance with your compass. I've measured from B going towards C to get where the turning point is. You know it'll be the same on the other side. So I place my compass in the corresponding point at B, and I mark towards A, and I mark towards C. That gives us our turning points. Draw in the vertical line, and then we're going to get the height from the front view. Here is A going to where B is, so we need this distance of the turning point over here. So that was between A and B. On the other side, between B and C, we need this bottom distance. And that is our second turning point between B and C. There are all the points that we need. I'm now going to go over them in a dark line, as well as drawing in the fold lines. There you have the completed drawing of page 83 and the development of the branch pipe, showing where the turning points were.